Rocks are like pastry and bread. Rocks are of a mixture of minerals like quartz, clay, feldspar, and mica, just like pastry are a mixture of ingredients like flour, starch, sugar, and butter. Gems in rocks are like nuts in pastry. They influence texture and color. Ingredients like aluminium, calcium, sodium, potassium, magnesium, and hydrogen in rocks influence texture and properties just like sugars do in pastry. Ingredients like beryllium, chromium, iron, copper, gold, and sulfur give color and properties to rocks just like spices do to pastry. Mixture of minerals are baked in the bowls of the earth to form a variety of rocks. Depending on how rocks or pastry are cooked, they can be fluffy, soft, crumbly, flaky, or hard. Equipment needed: volcanoes to cook, bake, blend, melt, spray, and spread. Gravity to run the rivers so that erosion can cut and carve. Wind to shape. Water to polish. Ice to crack and to accumulate into glaciers. Glaciers to grind. Earthquakes and comets to mix and mash. Oceans to press and roll. And life to cement, bind, and carve. Preparing the ingredients. The ingredients for rocks are minerals made from the atoms like silicon, oxygen, aluminium, magnesium, potassium, calcium, sodium, hydrogen, beryllium, chromium, iron, copper, gold, sulfur, etc. These raw ingredients are provided by the molten magma beneath the Earth's crust. Take 1 cup of silicon, 2 cups of oxygen, mix thoroughly until it hardens and crystallizes to quartz. Quartz is SiO2 and is also called silicon dioxide or silica. Depending on how it crystallizes, it forms various varieties of quartz. When the crystals are big and have impurities, they form pinkish violet to deep purple crystals called amethyst. When the crystals are dense and microscopically small, they form big rocks called chert, which breaks into flat pieces called flint that produce spark when struck against steel. When chert has impurities embedded in the crystalline structure, it is called jasper. If jasper has iron, then it is red. If it has emerald, then it is green. When the crystals are even smaller and denser, and if they are embedded with other minerals, then parallel layers or bands are formed as seen in agate. When silica crystallizes in single chains interlocked with magnesium, iron, aluminum, and sodium, jade, a green gem, is formed. Garnet is quartz crystals with calcium accompanied by iron, aluminum, or chromium, or aluminum accompanied by iron, magnesium, or manganese. When fibers grow very, very long, they form silicate fibers called asbestos, which are used for insulation. When the fibers are breathed in, they can cause lung cancers to grow. Take quartz and add aluminum and fluorine to get topaz. Take quartz and add magnesium and iron and oxygen to get pyroxene. Add more magnesium and iron and oxygen to get olivine. Take some quartz and add aluminum to get clay. Sprinkle potassium, calcium, and sodium and let it harden till it becomes feldspar. To make lazurite, mix feldspar and add sulfur, oxygen, and chlorine. To make sodalite, mix feldspar and add sodium, oxygen, and chlorine. Add hydrogen to feldspar till it becomes flaky and slippery mica. Take quartz and add magnesium and hydrogen and prepare some talc. Cook talc till it turns to soapstone. In another bowl, substitute silicon, the basic atom of rocks, with carbon, the basic atom of life. 1 cup carbon, 3 cups oxygen, 1 cup calcium. Mix thoroughly until it hardens and crystallizes to calcite. Add magnesium to make dolomite. Add phosphorus to calcite to make apatite used for bones. Add sulfur to calcite to make anhydrite. Add water to anhydrite to make gypsum used for walls and houses. Gypsum can grow crystals bigger than 10 meters. When the crystals are very small, alabaster is formed that makes translucent rock often used for ornament carvings. When gypsum is heated, pulverized, and mixed with water, it forms plaster of Paris. Mix and heat iron and sulfur until it turns to pyrite that looks just like gold. To make lapis lazuli, mix lazurite, sodalite, pyrite, and calcite, and heat and press. Metals are useful as coloring agents. Use a pinch of gold for gold, a pinch of iron for red, a pinch of copper for green, a pinch of magnesium for blue, a pinch of sulfur for yellow. To make decorative gems like aquamarine, emerald, opal, sapphire, and ruby, take some clay, add beryllium to make blue aquamarine. Add chromium to aquamarine to turn it into a green emerald. Turn quartz into opal by soaking it in water until an ocean is seen inside. Mix aluminium and oxygen and make some sapphire. Add chromium to sapphire and make some ruby. To make tuff, basalt, granite, sandstone, quartzite, limestone, marble, shale, slate, schist, gneiss, peat, coal, and asphalt. Glaze magma to make glassy obsidian, which is just volcanic glass. Pop some magma to make scoria, which is volcanic cinders. Whip some magma to make pumice, a volcanic foam. Mix and knead the above into a dough and gently bake to get porous stuff made with small pieces and breccias made with large pieces. To make fine-grained rhyolite, high in quartz, and basalt, low in quartz, take magma and rapidly cool it. To make coarse-grained granite, high in quartz, and gabbro, low in quartz, take magma and slowly cool it. To make sandstone and quartzite, roll quartz into a flat sheet, press and fold to make sandstone. Take sandstone and under heat and pressure let it crystallize into quartzite. To make limestone and dolostone, mix quartz with calcite from seashells and press and heat until it turns to limestone. Add dolomite to make dolostone. Soft limestone is called chalk, used to write on blackboards. Travertine is a limestone formed by rapid precipitation of CoCO3. It is deposited by hot mineral springs on ceilings of caves as stalactites or on the floors of caves as stalagmites. To make marble, heat limestone or dolostone in a pressure cooker until it turns to marble. To make slate and gneiss, crush quartz till it turns to silt and mud. Mix with clay and calcite and let it harden to shale. Press shale to slate to make a rock that splits into flat surfaces used to make roof tiles and blackboards. Press slate to phyllite. Press phyllite to schist. Press schist and add feldspar to make gneiss, hard enough to use on the side of roads. To make coal and asphalt, take a cup of plants, pressure cook them till you get a black, greasy sludge called hydrocarbons. Simmer till it hardens into peat, pressure cook until it's coal, and mix sandstone with hydrocarbons to make asphalt. To make diamond, press and heat coal to make graphite. Press and heat graphite to make diamond. Diamond is the hardest mineral with a hardness value of 10 on the mole scale of mineral hardness. In comparison, talc is 1, lead and graphite are 1.5, calcite and gold are 3, a fingernail is 2.5, a copper coin is 3.5, iron and steel are 4, obsidian and tooth enamel are 5, a knife and window glass are 5.5, a steel file is 6.5, feldspar is 6, quartz and unglazed porcelain are 7, topaz and hardened steel are 8, and ruby and sapphire are 9. Mohs scale is ordinal, showing only the order of hardness instead of how hard a material really is. Topaz with a value of 8 is half as hard as a ruby with a value of 9, and diamond with a value of 10 is 4 times as hard as ruby. Using calcite from limestone as a cement and sand and gravel as a filler, man can make any types of imitation rocks he desires, like concrete, porcelain, glass, plastics, and IC chips that are carved into computer brains. Man is not the only living thing that can make rocks from minerals. A tree can make rubber, and an oyster can deposit CaCO3 in concentric layers to make a pearl.